The topic of my talk is about containerized web processing services and a little bit more about the technical details and the benefits and some of the drawbacks. I created this kind of system together with a colleague here at GFZ, Matthias Rüster, and some order code and some consulting with Massimiliano Pettore, who is now at the EURAC research in Bolzano, and also with some order code from Benjamin Pross here from 52 Degree North. I hope you see the agenda now. This is also a bit question.
Yes, it works.
Okay, great. So originally I thought about talking a bit containerized web processing services. So container is the WPS itself and the containers, but we already learned a lot about the WPS for today, so I think we can take that way shorter. The other points are the benefits, the problems, and some future developments that we want to do, at least in the context of the RIESGOS project. Right, the RIESGOS project, maybe just some words. I don't know how much Matt has already said, is a multi-risk analysis information system platform for the Andes region. And the part of the GFZ was to contribute standardized web processing services for the interaction with other colleagues, other institutes. And our main point was where the earthquakes and some damage computations, where other has something like tsunamis, lahars, floods, and so on. The WPS, yesterday there was a talk from Benjamin Pross about the WPS itself. We also heard about that for the Coders project, for example. We just have a standardized interface for doing like arbitrary processes, arbitrary computations over the web. And currently we have there the version 2.0. There are different implementations that implement them up to a different degree. For example, the PyWPS only supports the version 1.0, so that was not like the primary choice for our RIESGOS project. Also, there is some ongoing work on the OGC API processes, which is, from my point of view, really interesting. In the Java world, like we work with the WPS implementation by 52 Degree North. In this case, we just have an interface and have some with some methods to implement, and then we can implement algorithm A, B, C, and so on. If we just provide this basic get execute process and some process description together with this description for the input and output data types. Now we were a bit more into something that wasn't mentioned that much today, which are the containers, which are lightwise virtual machines that mostly share the same kernel with the operating system and just run their code into different user spaces. Most prominent is Docker. Like a lot of people use Docker, a lot of people talk about Docker. Docker is a buzzword at the moment, but there are others as well. For example, Singularity, and also others outside of the Linux world, like the FreeBSD jails. Like what we use Docker for, normally we have some kind of web-based architecture with a database, with a web server, with a container per microservice, and so on. But you can really do a lot of stupid stuff with Docker. For example, if you broke your package manager like me, you can run PDF LaTeX in Docker and install the dependencies there. So what is the difference in our approach at the moment for containerized web processing services? We still have like a server, a WPS server and a Docker image. And we put each of the servers, so each of the process of the logic into its own image. If you would think about having like REST API, it would be like putting all of the post requests into another image, which is something really, really different from the granularity point of view. And I guess nobody does it up to this extreme. at least not in the normal web processing way, in the normal web design way, sorry. And to support that, we have like one generic base process that we initialize with configurations. I think the Bocardis did it in a similar way. He mentioned this this domain model, and there were also like the inputs and bounding boxes and something like that included. This is similar, I think. Why we do all that stuff with Docker? At the moment, I started with the RIESGOS project. We had like a lot of already existing Python scripts that had to be included in the WPS, so that other institutes can run their code there. And I really had no idea about Docker at all. So it was a great learning experience to do that. But we also have like some kind of real reasons. Otherwise, I wouldn't make this talk here. And to see that, maybe we can take a look into the architecture. I tried to visualize that a little bit, where we have some kind of JSON files. I hope you see my mouse cursor.
Yeah, we can see it.
That is used to specify like what kind of process we want to execute, where to get the input data from, where to store output data, where to interact with Docker at the basic level. Otherwise, we have this Dockerfile, which just describes our environment. I mean, this is basic work with Docker. I guess everyone has kind of Dockerfile with all this installation, all this environment variables, and so on. What happens when we start a process is that we create a Docker container out of the image that we specify in the JSON config. We then have some copy process to get our input data into the process container. I will talk about this kind of I/O in a moment. Then we have the stage to run our process. In this case, let's say it's a Python script, because we did that a lot in RIESGOS, but it's meant to be whatever executable you want. And after this is done, we copy the outputs out of the container and remove the container afterwards. So if we take a look at this architecture, we really see this kind of separation between the server on one side, here on the up, and the process code itself on the down, on the bottom. So this is really a clear separation of the responsibilities also, and it made the system really, really flexible, and also has a lot positive impact on the maintainability. So we use Docker images. We can write like our own ones, but there are a lot of existing images out there. There are images for Python, there are for Node.js, for Ruby, and so on. There are really a plethora of existing Docker images out there to reuse. Another thing is that we have this Docker image ID, which stays the same once the image was created. And this gives us like service integrity. You are really, really sure if you give the JSON configuration file here, the Docker image, that it runs exactly this version of the code. There is no opportunity to run something newer, something older. It's just write this version that you specify. The other thing that we have with the Docker image is the dependency management. And this also is on a level that we can specify a Docker file for our Python 2 environment, one for our Python 3 environment, and we don't have any problem that all those versions would interact with each other. So there is no problem that we have an older version in one process or not a new version in the other one. So they're really, really separated, and this is something that makes it really, flexible to work with all kind of codes and scripts that are, that are used in our pipelines. Sorry. Another benefit here is the Docker file system. As you saw here, we like create the container, and we dropped it at the end. Docker's file system supports that. For us, it's kind of using it as a hack to garbage collect our file system, because we have the benefit that all of the code that runs inside of this Docker container doesn't interact with any other code that runs into another Docker container. It is just really this run, and you have another container for the next run. So if you have like temporary files in your project folder for example Python code, you download some data and process that with GMT, for example, then you have no interaction between these runs based on these splitting in containers. Otherwise, it would be really, really hard to realize these kind of interactions once they happen. And the real benefit, and I talked about that already, is this encapsulation, this splitting of dependencies. We have to generate a generic base process that are maintained by IT staff, and the command line applications that are wrote by scientists. We then support them on writing the Dockerfiles and the configurations, and then any code in any language with any environment can run on the WPS. But we also have some drawbacks. One thing is that this kind of generic base process, I don't know about the experience that they have in Vocadis, for example, but at least from our point, it's really hard to make one basic process for all kind of stuff. Just because having error handling managed properly is really different if you have some kind of Python script that you execute, or you have some JavaScript, Java file, Java class to execute, or some C or Fortran code. This is really different, and it makes the whole generic approach kind of hard. But once this is done, you have a lot of benefits from out there. The other stuff is because we have these kind of additional Docker logic with the generic base process. Sometimes errors are really hard to find. And maybe I try to visualize this kind of lasagna code having different layers in the overall system. And these are just the, let's say, the systems that run. If you would think on a call stack, from the basic server up to the point in a Python code where maybe some error happens. This is really a huge call stack, and it is even not clearly that you see your errors that happen in this Python script in this stage. Sometimes you have that only on the output generator when there is some kind of incompatibility between the stuff the Python script generates and the stuff the Java server wants to write out to the client. And in this case, we all should be aware of debugging, that it's really, really hard. I really love this quote by Brian Cunningham, which says, debugging is twice as hard as writing code in the first place. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. And this should be really, really a point if you are going to make your systems complex and complex and complex. The other thing is, Docker itself has some kind of overhead, but also the I/O mechanism that I said earlier has some kind of overhead. So if you are going to get your input data from the client somewhere outside here, and you have to copy that to a container as an additional step, this is overhead as well. And that should be mentioned. For us, in our case, it wasn't that an issue because we had only small files that we sent over the web anyway. But for example, from what I heard about Vacodis, it's really an issue. You don't want to send like an image repository over the web and then copy it to a Docker container. The other one is the basic Docker performance overhead. And we made some small tests. In this case, it's a performance test for our damage computation. And you can see that we have some kind of overhead from the green one native to the red one to Docker from around 30%. A colleague also mentioned that it can go up to 50%, which is kind of huge from my point of view. But there are opportunities to lower these overhead a bit by setting the security profile of Docker. So we have only around 8% overhead. In our scenario, we were able to do that because we managed both the server and had an idea of what kind of code runs on the machine. But for like a general edge processing service, that would not be something you want. Another thing to mention, it still matters more what kind of code you write than the Docker overhead, because in this example here, this is a performance test that we had for the damage computation, as I told, but the basic test criteria to pass these tests is not about 15 seconds or 18 seconds, it was about 60 seconds. And we spent some time to optimize that code. But if you really want to do high performance computing and care about every millisecond because it just aggregates to a huge number of hours, then you don't want to put that in Docker. So if I mentioned the drawbacks, so the question is what to do. For the complexity, I just said one generic base process is hard, but we use that over and over and over again. So we identify the errors and we improve the stability way faster than compared with a case where we just had like a scientific code that runs once a month. For the scientific code itself, test-driven development has shown to be really, really valuable. And I would not suggest anyone to do it without. We also had some integration tests that we did with the JMeter, so to test both the WPS, the integration, and the scientific code. And last but not least, monitoring and logging is essential. But this is also hard as well, especially the logging, because we have this strong splitting between the scientific code and the server code. For the performance, there are approaches to work with Docker volumes to mount the data into the data into the container. I just wrote 52° North implementation because I wasn't aware of the real name for the Ocadis project, where I think is where they did exactly that. Another stuff is like testing with singularity, which is like Docker, but especially used in high performance computing scenarios. At the moment, we have no experience of that, but it still is something on a to-do list to check out. Same is true for native runners. Say if you are really, really sure you have all your dependencies, you have you don't have any temporary files that can create a mess up. Then you also should be able to use a like native runner right natively on the machine, but then it's not Dockerized anymore. So this is not to talk about it here further. Another stuff is because we are in a Dockerized scenario. We can say we can split our problem into smaller parts and process them in parallel. In an extreme case, like in edge processing, computing it on a cloud next to the data. But for our RIESGOS project, it wasn't that necessary to care that much about performance, at least not from a Docker point of view. So we haven't tested that yet. And now we are on the further development steps. As already mentioned, we want to test singularity on native runners. We also want to migrate to the Java PS because of the upcoming OGC API processes that, at least from what I understood, should be supported in these newer implementation. And also similar to the RIESGOS project, we want to go on with an event-driven architecture in RIESGOS 2. So that was it from my side. Thank you for your attention.
Hi. Yeah, I think that question was answered already towards the end, right? So why did you go for copying data into the container and out of it instead of using mounts?
So for us, it was really having a clean file system, like for every run, because a lot of these Python scripts that we managed really have these temporary files, calling them with GMT, with other tools, and just to get rid of these mess to manage that.
Mm-hmm. So you're not requiring the process script to sort of have separate temporary and output directories and stuff like that. So you can do whatever you want, basically.
It was meant to really support these whatever you throw into scenario.
Yep. All right. Thanks.
I guess there should be time for one more question. We saw another one from Derek on the Mover app. Derek, please go ahead.
Yes, yeah. Sorry. Yeah, as it says there, just interested about, obviously monitoring, it's an issue for us as well, running multiple Docker containers. But you've now separately got Docker, and I know it's unclear if you're running WPS server itself in a container, you might be.
The server runs in a container as well.
Yeah, as well, yeah. So you should be able to pull all of those all those logs out into an external monitoring service, and you can then run, and there's quite sophisticated tools now to kind of see exactly where errors are occurring, which container, at what level of detail you need, and to filter it out. And that might assist in terms of managing a more complex system like this.
Well, at this point, we were not exactly able to monitor all the stuff inside of Docker, because we also use the std in and the std out and the stdr as opportunities for giving output from the processes.
Yes, and those should write, as far as the containers concerned, those are available externally in the Docker logs. So you would be able to route those logs to an external monitoring system, which has the advantage that even when the container goes down, you still got access to those log files.
Yeah.
Pretty good. Thanks for the questions and the discussions, and especially to Nils for the good presentation. Thanks.